I want to share with you today about the research group that I have started at MIT, and we are called Space Enabled. And because it is space, I have something small for you. What is it that you have to have before you launch a mission? After you've done all the technical design, and you've chosen a very clever acronym, a very clever name for your mission, what also do you make? Who knows? What does every mission have, whether it's from the US or from Europe? I heard it. Say it again. A logo, yes? Thank you. And because we are a space research group, we also need a logo. So I brought with you our logo. It is called Space Enabled, so it's an S and an E. So I brought one to share with each of you, and I'll pass them around now. So may I have a volunteer who can help me pass out the stickers? Who wants to help me? I need some help. You can help me, because you've said there's the logo. Whoop. So please take some of these and just share with everyone. Okay. Take the collection. Now is good. You can just do it while I'm talking. I'll take some more in case you run out. So the reason we have this logo is because we want to say that technology from space has a benefit to society. When I was a student like all of you, actually you can also just take a handful and give it to each row. It's even faster, if you like. But it's your choice. I leave it to you. Technology from space has a direct impact on people all over the world. And when I was a student, I was very frustrated because I spent time learning the equations and the theories for how to design spacecraft and aircraft, because I was in the aerospace engineering department. But I was also interested in how people lived around the world, especially in other countries, for example, in parts of Latin America or Africa or Asia. But I thought my training in space would have no connection between my international interests and my training as an aerospace engineer. But I'm here today to tell you that no matter what your interest is, we can find some connection between space technology and your personal mission to change the world. How many of you would like to do something to change the world with your work? I thought so. I think students today, we want our work to matter, yeah? We want to make a difference and improve life. So that's why we are here. So we are the Space Enabled Research Group, and we talk particularly about how we can use technology from space to enable sustainable development. Now, since I'm in Italy, I have learned how to say this part in Italian, but I will practice with you. And so we want to support sviluppo sostenibile. Is it good? Thank you. Thank you very much. I do not speak much Italian, although I speak some Spanish, so maybe it's not so hard. Now, I want to ask you, what do the students in the room define as sustainable development? Can I have some examples, please? Please tell me your definition for sustainable development. If you want, you can start with development and then say how it can be sustainable. You have some time to think. And if you prefer, you can say it in your own language and someone will translate for me. Go ahead.
Eco-friendly, and the development of present doesn't affect in a negative way the development of future. Something that benefits mankind.
Thank you so much for being the first brave one to answer. Anyone else? I'd like to hear another answer. Good. Perfect. We need another answer as well. Please, I will walk this way. Anyone here? Yes. We're looking for definitions of sustainable development. Yeah. All of you said you want to change the world, so I know you have some idea. Yes, thanks.
Hello, I'm civil engineering, and I'm interested in infrastructures, and so they have a low impact on the ambient or environment.
Thank you. I'm so glad you're here. We need our civil engineering colleagues because otherwise we are just going to produce a lot of information, but we need you to help implement it. So welcome. Thank you. So infrastructure and making our infrastructure more effective while not impacting the environment is one example for sustainable development. Welcome. Any other examples? Over here? It doesn't have to be a complete example, just any examples, okay. Yeah? Is this a hand here? Thank you. Good. Can you help me pass it to them? Excellent. Thank you.
To improve the possibility to produce new products while recycling the old one not used anymore.
Thank you. Of course, because we manufacture many items, right? We use materials, Some are artificial materials like plastics, and some are natural raw materials. And of course, we are always using new ones, but now we have a lot of trash, a lot of waste. So these are all great examples. And I think what's important is, in order for us to make progress, we have to decide how we can use the tools we have from space in all these various issues. So for us, we think about this question. Before I tell you my definition of sustainable development, I want to ask you to go with me on a journey. Are you willing to go? Okay, good. Good. You're very welcome. It's good. So now, please close your eyes. Thank you. Everyone close your eyes. Students and everyone. So I want you to please, we're going on a journey in our minds, but please imagine that you are standing in a place that actually is the same temperature as here. It is in Central Florida. This is where I grew up. And the year is 1999. You are standing outside near some water. And about 3 miles away is a dark place that you've been staring at. Now it is late at night. You spent the whole day working in an office, but you've stayed up late, it's around midnight, because you want to see something very special. It's the third night in a row that you are doing this, because it should have happened last night and it was canceled, and the night before also it was canceled. But you think maybe tonight it will be successful. And now you're watching your phone to see what time it is, and you're listening to the news on the radio. And then they start the countdown. 10, 9, 8, 7. You think maybe they won't cancel tonight. 6, 5, it could still be canceled. 4, 3, now you're starting to hear something. 2, 1, open your eyes. Now they have ignition and blast off, and first you see a very bright light, and even though it's midnight, all the sky is as light as if it was the middle of the day, because the space shuttle engines and the supporting engines on the solid rocket boosters are all ignited, and they're letting off all this light and steam from the water that's produced from the space shuttle main engines. And a few seconds later, you feel the great vibration of the sound traveling about 3 miles across the water to hit you right in the chest. And you feel as though everything is shaking, but it feels very exciting. And this is the launch of the Chandra X-ray telescope. Has anyone heard of the X-ray telescope called Chandra? It was launched in 1999, and I was fortunate to be there. I'll tell you, I was 17, so you can figure out how old I am now. And I was working as an intern at NASA's Kennedy Space Center. I was very lucky that they were allowing us as interns to go wherever we wanted to watch the launch. So we were standing next to one of the biggest buildings in the world. Who knows the very large building that they have at Kennedy Space Center? What is it called? Anyone can help? It's the vehicle assembly building, where it's true, they do vertical assembly. And so we were standing right next to it, which is one of the closest places you can be to watch a launch. And so I was so thankful. Obviously, as a 17-year-old, this was very inspiring. And even though we had to wait 3 nights after 2 cancellations to see it, basically you could say this is the moment that made me want to become an engineer and to become a part of the global space program. Now, I didn't really know what engineers did, but I thought it would be very interesting to join the large teams. It's also very good to share that that summer, 1999, there were a lot of important things happening, and this launch was for a telescope. But what were the other launches for that year? Does anyone know some of the important launches that would have happened around 1999? Thank you, it was for the International Space Station. So it was during some of the key construction periods. So on the ground that year, the US laboratory was being prepared for launch. But in my team, every day we had a telecon with people from Italy, because the Leonardo multi-purpose logistics module was right there as well in the high bay, getting ready to launch. So my very first space job was mainly on projects with Italy, so thank you. And I was excited to join this large global team and be a part of the ones making the future of space. And it allowed me to learn about how we get pictures like this. This is an image from the X-ray telescope. I thought, on one hand, they're very beautiful, but of course, they're also unlocking the secrets of how galaxies are formed and what's happening at the edge of black holes. So this inspired me to go to MIT, and I was fortunate to take on research opportunities and to study engineering. It wasn't easy. In fact, there were times when, as an undergraduate, I really felt I didn't understand the topics. So if anyone here and you're feeling frustrated about the classes, don't give up. I did not expect to become a professor. It was something that I was just diligently working, but it was challenging. And there were times, many times, and I asked for help from friends and from faculty to get through the classes. But I tried to at least finish everything. That was my main goal. And some faculty gave me good advice on how to prepare for graduate studies. And with their help, I was able to prepare. Meanwhile, I was following this engineering path, but I had another interest, and I also traveled every summer to Kenya. So here I'm visiting a school, and it's designed to encourage girls who have come from very poor families. And they've been living in a slum in a part of Nairobi called Kibera. And so this school allowed them to have better education opportunities and a safe place to stay. And I would spend time with them practicing English and math. And they taught me some Swahili, as I learned a few words. And while I was there, I was thinking, well, I like space technology. I like working at NASA. But I also like volunteering with girls in a school. And I didn't think the two were connected, but I was frustrated because I thought, what kind of job do I want to have in the future? Should I spend my time with girls from Kenya and help them with their education? Or should I spend my time building satellites to make telescopes for the universe? I was frustrated and worried that I'd have to make a choice between the two. I didn't want to. And that is why I started to ask, how does a country like Kenya use technology from space? And what I learned is that Kenya already had many professionals, you see some of them here, who regularly use satellite data as part of their national development. So this is a regional center for the mapping of resources for development. It is located in Nairobi, Kenya, and they have a lot of expertise, and they use satellite images and measurements about the environment to make decisions and policy recommendations to improve areas like agriculture and flood monitoring, and to understand how they can plan development in the country better. And once I saw that it was not just a question of whether I could do international projects or space projects, really I could do both. And now I have a career focused on asking how we apply technology from space for sustainable development. So I'm so thankful for the mentors who taught me these things. Here you can see an example from the Department of Remote Sensing and Resource Survey in Kenya. And both at the regional and national level, they have knowledge and tools to take data from space and other tools like satellite communication and positioning and apply it to improve their own country. And this showed me that this could be part of my work as well. So our key goal, and if anyone asks you, why are we investing in space technology? What is the purpose and what is the benefit of all the engineering we are doing and all the science? Please tell them this sentence in whatever language you like. Tell them that technology from space is helping every country on Earth to reach the Sustainable Development Goals. Now, who here is aware of the Sustainable Development Goals? Raise your hand. Have you heard of them? So these are the, I think it's Objetivos de Sviluppo Sostenible. Is it close? Yes? So we can say it in many languages. And let me talk about what they mean. Shown here is the graphic, which is 17 boxes. But please know that under the boxes is a great deal of thinking. In fact, each box has dozens of metrics or indicators that are quantitative ways to ask, how are we doing as a global community, in reaching sustainable development? So this is a development definition that I use because it's been agreed upon by every country who's a member of the United Nations. So every country has agreed to use these metrics to ask, are we making enough progress to make sure everyone has a safe place to live and food to eat? The very first goal is to eradicate extreme poverty. And this means to make sure that there's no one who is living on less than about €2 per day. Now, this is a big idea. And in fact, it's not clear whether it can be done. How many of you believe it's possible to eradicate extreme poverty? What do you think? We have some optimists in the room that it's possible to eliminate extreme poverty. Is anyone who thinks it cannot be done? That we will always have extremely poor people in the world. So it's fair because, in fact, what you have to ask is, do we believe that the leaders and the communities around the world are going to do the work that's necessary? I think what's true is we know it's possible in theory, but we have to decide if, politically speaking, and at the community level, we are going to make the change we need. But the good news is, between 2000 and 2015, we had another set of goals. Who has heard of the Millennium Development Goals, the MDGs? So it was the previous generation before this list. And during those 15 years, in fact, the goal was to reduce poverty by half. So you could measure across the world who is living under extreme poverty. And actually that goal was met because the overall global welfare went up. And you could say that now half the people living in extreme poverty were cut down. So, in theory, if we really commit ourselves to this work, at the government level, but also at the local level. For students and for every job, it's possible to reach these goals. The other ones are in ensuring access to clean water for everyone, ensuring everyone has enough food to eat, ensuring everyone has access to basic education. These sound like simple things, meaning obviously everyone needs food and water and education, but still we have challenges around the world where it's not equally distributed. But even beyond these basic needs, I like that they have some more advanced ideas, such as ensuring gender equality and making sure that people have access to fair treatment from their government. So again, behind these 17 goals, there's a long list of very detailed items we need to measure and we need to improve. And I'm sure on the list for each of you, when you raised your hand to say you want to change the world, somewhere on this list is your idea or your area. So I encourage each of you, please study these goals online and find the one that makes you most excited and say every day, whether I'm a student or whether I'm getting this very nice job that the master students are going to get soon, you're doing something to advance these goals, both in your own neighborhood and maybe also around the world. So in my work, I believe that we can advance justice by pursuing these goals because the earth is full of complex systems, meaning the systems that provide access to water and education and government service. They are all made of a complex combination of technology and people and the environment. And we can use technology from space to improve the design of these systems. Now, as of today, we can already say there's some good news because there are already technologies, in fact there are 6 I'll show here, that are being used every day to support sustainable development. So here I showed the examples of satellite Earth observations, satellite communication, satellite positioning, microgravity research and the advancement we gain from human spaceflight, as well as technology transfer when you have one technology designed for space, but you move it into a different sector, like civil engineering perhaps. And then we also have the broad category of inspiration, where you design something and you do research about basic space science, but even that adds to the education and the inspiration for students and adults around the world. So I want to give you some brief examples of how these are being used today, but the message I have for all of us as engineers and scientists is that there's more work for us to do to make sure that these benefits are distributed to every country, not just to those that are traditionally involved with space. I also wanted to share with you the kind of team that I have that is doing this work with me. So I'm very lucky that I've just started a new position at MIT, and I'm forming a team of graduate students and professional researchers. And we cover these 6 kinds of ways of thinking or research methods. On the top, you see social methods, design and art and social science. Particularly, we're interested in history and anthropology, because our goal, before we do any development project, is to understand historically and socially what have been the major forces that have led to the current state. What's happened historically that has designed the current situation, and what do the people want to do for the future? This actually means mainly we're good listeners. Either through interviews or through observing what's happening, we find out what's happening from the community's point of view before we do a project. Then we use our technical skills to design some kind of tool along with the community, and this involves complex system modeling, satellite engineering, and data science. For you in the audience, does anyone think of themselves as a satellite engineer? How many here are satellite engineers? You have some? Do you work on designing satellites or even some aspect of satellites? Some subsystem or modeling? How many of you would call yourselves systems modelers, modeling and simulation? System engineers as well, yes? And how many of you are data scientists? Do something with data? Yeah? What other categories am I missing? I think some of you are close, but have different words. How would you define your work? Yes, yeah, thank you. You're a student, but you are studying something. What are you studying? You can say it in Italian too, it's okay. Aerospace, yeah, so we'll put that under satellite. So all the aerospace engineers can say you're learning to design spacecraft, yeah? So you can count that category. I want to show you, we see all these tools as coming together into an integrated design cycle. So it's not just that we do them separately, but we first use the social tools to understand the historical and cultural situation in a community, and then we combine the technical tools we need. And we do this in collaboration with various organizations. Sometimes we are working at the international level, So next week, I'm going to visit the United Nations in New York. Who knows one of the United Nations agencies? What do you have here in Italy for the UN? It's here. Yes? United Nations? Yeah, which ones are here in Italy? Oh, just give us any UN agency. Give us any United Nations agency. So these are space agencies. So I'm saying sometimes we do our work with the United Nations. Can you translate that? Maybe we can translate this one to Italian. United Nations? Yeah? Yeah? So there are a number of agencies underneath the United Nations, right? So one in Italy is the Food and Agriculture, FAO. That one is in Rome, yeah? And in New York, they have the United Nations Development Program and also UNICEF. Have you heard of these? So these are all groups that in some way can use technology from space in their work. So some of my research is working with these offices to ask how they can improve their own use of space as they are doing development work at the international level. I also do work with national governments. So recently I was visiting the country of Ghana. Where is Ghana? And what part of Africa? It's in the western part of Africa. It's good just to check because there's many countries in Africa, 54. So, and I visited the government of Ghana and met with the Minister of Science, Environment, Technology, and Innovation. And their concern now is on the question of monitoring the mining in the country. Who knows what valuable material you can find in Ghana? What would they be mining? It's gold, actually, and diamonds may be farther south in South Africa. That's right, so all the countries along the Atlantic coast there in Western Africa, that's known as the Gold Coast. So there's still gold to be found in Ghana, but some people are breaking the law by doing illegal mining practices. So now the government has a very focused goal to find ways to reduce this illegal mining, and they would like to use technology from space, whether it's images or positioning information to track where it's happening and to try to stop it before it creates more pollution. We also work at the regional level or city governments. So I'm going in September to Rio. Where's Rio? Rio de Janeiro. It's in Brazil, thank you. It's one of course, the most beautiful countries and beautiful cities in the world, so I'm very happy to go there. But they have actually a very high technology government at the city level. They have a beautiful control room with many screens and videos showing all the city. And they are also interested in improving how they use technology from satellites to monitor and help maintain the city. Then we also work at the local level, sometimes with very small startup companies. And so I'll tell you a story about that. But first I'll tell you who's on my team. If some of you were here, actually last year, you might have met the first person on the list, which is Dr. Javier Stober. He came and gave a talk, but mainly to the propulsion team here. He is a propulsion engineer. He did his PhD at Stanford. And he is our lead engineer in the team, and he is helping us set up a satellite laboratory. Others on the team are in all the 6 areas, including art and design, social science, satellite engineering, complex system modeling, as well as data science. And here I'm showing how all the different people bring some of those skills. So I'm very thankful because this team of graduate students and professionals, we are combining our skills together to ask how we can improve this use of space technology. And we also want to help develop the next generation of satellite design. Good. Let me give a particular example in West Africa. So we talked about Ghana earlier, and if you go just a bit west, 2 countries over, you come to another country called Benin. Does anyone know what language they speak in Benin? It's French, yes, and I do not speak any French. But when I went, I was thankful that the team could host me and do a lot of translation. So I was in Benin recently because I met someone from a small company there. And they took me to this village, which is called Ganvier. I was very happy to go there because I learned some of the history. It is a village that is made of people whose ancestors ran away from slave boats, meaning they had been captured to be taken into slavery and sold across the ocean to the Americas, but they escaped and ran secretly to this neighborhood, which is surrounded by water. And they formed a community, and over many years, they've been living there, about 100 years. So they are now a community focused on fishing, and they have their own local language. And you see they build their buildings right over the water. So the water is very important to their life. But they have a problem, which is actually common across many parts of Africa, and even in my hometown in Florida. You see here, the water is covered by an invasive plant. And this particular plant is called the water hyacinth. Have you seen it before? Has anyone seen this plant? Yeah, it's actually all over the world, and it's a very hardy plant. It lives very well, and it takes over whatever is there. So other plants tend to die when it's active. So it comes in cycles. It blooms for a while, and then it goes away. But even after it's died, it just floats to the bottom of the water. And actually, that's bad as well, because it changes the chemistry of the water and makes the river more shallow. So all this is a problem. And this company called Greenkeeper Africa, they are working to try to reduce the negative impacts of the plant. And their idea is to actually make a product they can sell based on this plant. Because they learned that actually it's very good at absorbing oil waste, and you can use it to clean oil spills in the soil or in the water. So they took me to visit where they do this. This is the team. It's a small company, and they're based in the city. But they hire people who live in this area of the Ganvier, and they pay that they can collect the plant and bring it to their factory, and they convert it then into this useful product. So they took me to the factory, which is right there on the water where I showed you. And inside, they've designed their own machines. And they take this raw material, which is the plant, after it's been collected and dried. And they put it through the machines and create these kind of fiber. And this is used to make packages they can sell to companies that maybe have machines or trucks that might have some oil pollution. And after this absorbent material has been sold, it's used to collect the oil, and then they bring it back and put it as part of a manufacturing process for cement. So the waste from the oil is turned into an input for another manufacturing activity. So they were doing this already for about 4 years, and I met them just last year. And they said, the manufacturing's going okay, but we have one problem, which is that we don't have a good way to monitor where the plant will be located, because it's located near a large lake with multiple rivers coming off of it. So it could be anywhere in this large area. They do not have a background in space, but they knew that there were people who have been doing studies to use satellite technology to monitor these kinds of plants. So now we were doing a research project to design a system that's easy for them to use to monitor the plant and other kinds of environmental factors from space. And the key thing is, it's not just that the data is sort of new scientifically, it's a little new, but what's really interesting is to ask, what kind of technology is going to be useful to this team? Because they do not want to get a PhD in satellite engineering or satellite data to do this work. They just want to have something very useful that provides an observatory that can be used by themselves and by the governments in the area to then apply this knowledge and track where the plant is. Then they can collect where it is and decide what's the right amount of the plant that's sustainable over long term. So we will use multiple tools. We'll use existing satellite Earth observation data, both from regular commercial images and from government science images. Who can give me an example of a European satellite that might help us find the plant? Do you guys track the Copernicus satellites? Which one from Copernicus might be useful? Sentinel's definitely our first start, right? Because the Sentinel and the Landsat data gives us basic images. Now, a picture is good, but it's not all we need, because pictures can just tell us a regional view of what's going on. So what we also want to know is what kind of environmental factors increase the likelihood of the plant. So scientists who've been studying the plant will tell us that the salinity of the water and the temperature and humidity might make a difference. So we want to measure multiple things. We'll also use satellite positioning, because even as the teams are going around, they have nice phones. So their phones have positioning radios, right? And so they can capture, okay, today we took a picture of the plant, and it's at this location. So eventually we'll have a nice database of satellite registered pictures, and we can mark where they are located, so we have something on the ground and something in space to match. We may also design sensors to put in the water and on the land, maybe in trees, to have images and other measurements. So now we are just starting, even this summer. I'll be going back to Benin in August. And before I go, I'll have a team of students designing a prototype for this initial tool. On one hand, to have the data on a website. On the other hand, to have tools to measure the next generation of data. So this is our first key project with the community. But you know we also need to do the social part, right? It includes listening to people from the community with social science and art and design. Because we don't want to just deliver to them, here's your technology, based on our own idea. What we really want is for them to tell us what they are trying to do and to give us their ideas for the technology. So I mentioned these 6 technologies, and I'll just check the time. How are we doing? I think now it's 3. We okay? What I want to say is that in each of these 6 areas, we have some benefits, but also some challenges to overcome. Already, I can give you many examples of how they're being used today to support sustainable development, but I also have a request for all of you, because we need more innovation to use these technologies even better. So I'm going to focus first on the example of satellite Earth observation, and we'll explore the benefits we see from it now, but we'll also ask, what are the challenges still remaining to make it more useful? So in the area of Earth observation, here I'm showing examples of the satellites operated by NASA because I used to work at NASA, and these are the satellites I know the best. And of course, I'm most interested in the Earth science satellites. NASA has about 20 Earth science satellites, and they're quite parallel to the missions that are done under Copernicus. There's great data sharing and exchange of knowledge between the European and the NASA systems. So some of these satellites are specially designed for very unique science measurements. You see the Cygnus constellation, they're measuring wind speeds during hurricanes. You see, of course, the Landsat series, which is taking imagery. All of these have some specialized mission, and many of them are collaborations between the US and Europe, as well as partners like Japan and India. And so we are excited for this international work. Now, some of the satellites I showed take pictures like this. Does anyone want to guess where this is or what is showing in the picture? What's in this picture? What is it? Fields, and what's happening in the fields? Yes, he's showing with his arm that there's a special tool to water the fields, and it's going in a circle. So all day long, it's spreading around in a circle, giving water. So in the end, you have a beautiful view from space, showing nice, perfect circles of areas that are wet and areas that are more dry. And this happens to be in the United States, in an area called Kansas, in the middle of the country, where there's many farms. But actually, I showed it to somebody the other day, and they said, oh, it must be in the desert. Which, it's true that in the desert, if you want to make sure you have agriculture, you would use a similar system. So this kind of picture from space, it informs us what kind of activities the humans are doing, but it's limited in its ability to give us scientific measurements. So many of the NASA and European satellites, they're also giving us measurements of particular variables. So here you're seeing actually a visual imagery, and it's an animation, I think. We can go, yep. And so it's showing a measurement which includes technology from satellites and also from measurements happening in the ocean. And they're measuring both the temperature of the ocean and then using a computer model to estimate the global currents. So here's an example where, we're not just taking measurements, we're also estimating a global cycle, in this case of energy and temperature, moving the currents around the world. And it's based not just on direct measurements, but on complex physics-based models. Another example shows a case where we combine data from multiple satellites. So first I showed you the ocean because that's actually where our weather starts, meaning the temperature of the ocean is what determines what kind of season we're in. Have you heard of El Nino and La Nina? This is just a way of saying what kind of cycle the ocean is for its temperature, and that then has a direct impact on the global rainfall. So this picture shows you measurements from about 9 satellite missions. You have collaboration from the United States, from France, from India, from Japan, and they're combining, actually every day, a quick summary of all the data measuring rainfall or snowfall in the whole world. And you can go online and see daily what has been the latest collection of data about both rain and snow. Who knows what kind of sensor you use to measure rain and snow? Any guess? It's not a picture. What kind of sensor do they use? I heard radar, yeah? So it's microwave. And it's both passive, meaning one is a sensor just receiving microwave radiation, and it's also active on the radar side, where you send out a radio signal, and it bounces off the rain and the snow and comes back. So in this case, a satellite called the Global Precipitation Measurement Mission was built with collaboration between NASA and Japan. And there are many other similar missions that are collaborating to make this picture. Okay, so now we know the temperature of the ocean, and we also know whether it's raining or not. A third thing we might want to know is the rain increasing the vegetation and the health? Because now we can find out which parts of the world have in danger of either too much rain or for flooding, or perhaps too little rain, and maybe they have a concern for food insecurity or for a drought. This picture uses several kinds of satellite observations, one for the land and one for the ocean. And it's observing chlorophyll, either as vegetation in trees or as the animals and plants in the ocean that produce chlorophyll. And it's showing us the annual cycle of, we call it respiration. It's like breathing, right? So the earth breathes in all the good carbon dioxide and breathes out the nice oxygen for us. And we can see it from space. And this kind of information helps us monitor where there is concern for famine or drought. And already there are teams that take this kind of result, and they make plans to either provide food aid or make some plan to address where there might be some either increase in food prices or not enough food to serve the communities. Especially in several parts of Africa, there's a project called FuseNet. Who has heard of the Famine Early Warning System Network? You can look at it online. If you just go to fews.net. And it's an example of collaboration between several governments in Africa and the United States and several agencies. And they use this kind of result, and every month they publish a warning saying where there's a concern for famine. Now, having all that nice data is okay, but often what we need is a tool like this. I draw this from my colleagues. They are from a company called Blue Raster. They're basically a data analytics team, and they take all that fancy data I just showed you and put it into tools like this one that are designed to be used online, that are basic maps, and they're also interactive. So as a user, you can change something and you can search for something, because that way, rather than you having to look at every single kind of satellite data, they've combined everything for one theme. So in this case, you're asking which countries in the world are at risk of not having enough water. I think we have a colleague here who's studying from the State Department, and he's told me he was studying issues of conflict and how they're driven by lack of water. So perhaps you might want to reference this tool called Aqueduct. These are the kind of tools that make it easier for the average person to harness data from space, but we need more of them, because now they're often funded either by government researchers or by nonprofits. And the question partly here, especially for those of you who are interested in changing the world, is how do we make this data more effective? Now, how many are interested in starting your own business? Who would like to be an entrepreneur? There's a few. Raise your hands higher. I actually can't see. I see a few. How many of you would rather work for a big company that already exists? A few others. How many of you want to work for the government? Now, some of you have not voted for any of these, so maybe I'm wondering what job you want. Maybe you want to work for the university? Okay, maybe. How many of you don't know where you want to work yet? That's fair. Actually, I had the same question when I finished my PhD, because I had been in school for 12 years. It's a long time, but I had fun. At the end of my 12 years, I said, I really don't know if I prefer government or entrepreneurship or academia or industry. And so actually, I tried all of them, almost. I actually didn't start a company yet, but I'm working on that. So instead, I spent 2 years doing research at a university, and I went to a company for about 2 years, and I went to the government for 2 years. And I compared each environment. And in the end, I say all of them can be fun. I found something I liked about each one. But for me personally, I enjoy academia the most. But I'm so glad I've worked in government and in industry, because now when I meet somebody who's in the industry, I know what their life is like. I know how their place might work and what affects them. So actually, it's good to explore, and you're free to try all three if you're interested. Here we have an example of a team in Kenya that uses the data about the rainfall and the vegetation to help improve farming, and this one is showing a tea farm in Kenya. But the reason I show you all this is to say that we do have examples where people are directly using data from satellites for development. But we also have questions about what will be the future business models to transfer the great data we have into either companies or other groups that can apply it directly, because really we have a lot of data that's just sitting on a server, either for NASA or for ESA, and no one's using it. But we need all of your good ideas to transfer it out to society. I show here a lot of words, but the idea is that they're all the steps that are needed to go from building and operating a satellite all the way to the end where we deliver the information and someone uses it. There are about 8 steps in this value chain. The beginning is engineering and science, but at the middle is social science and business, and the very last stage is really a delivery of a product commercially. So we need your ideas to help transfer as we go from each science step and transfer it off to someone in business, which could also be you. You can study the business and the policy to use your skills in that area. So let me just give you a few more examples, because we're almost out of time, but I want to have time for discussion with all of you. So I mentioned that there are 6 different technologies from space that are already being used to support development. We talked about Earth observation, and I'll briefly explain some of the others. The first is satellite communication, and this one we use generally to provide TV and internet and radio and phone access around the world. There are some parts of the world where the best way to make connections internationally are partly using satellites. But what's also important is the social benefits. Who can show me which country this might be? Some of you may know the flag. Louder. This is India. And China also, of course, has their own space program and rockets and the ability to launch communication satellites. But I wanted to highlight the example from India, because India, throughout their history, has been involved with space for many decades. And from early on, they were committed to using the technology from space to serve the needs of rural communities. They were some of the first to provide satellite-based television broadcasts all over the country, and to ensure that there was some access to information or internet connection using satellite technology. So here we have an example of a satellite communications application. Who can tell me what's happening here? Any guess? Go ahead. It's a conference about, what do you think it might be? It's a particular kind of conference. Say it louder. It's a doctor's. This is a telemedicine session, which I know you have to just guess, but good job guessing. So the idea here is that part of what the Indian Space Research Organization does is to ensure that there are services for telemedicine, especially for remote areas. Because in India and in many countries, and it's true in the US as well, the specialized doctors tend to work in the big cities for many reasons, partly due to the way we give doctors jobs. And sometimes people in the smaller towns don't have access to a specialist in certain kinds of cancer or diabetes or special needs they may have. So they might need to travel many miles to see the doctor. But it's expensive anyway. So it's important that they can at least meet with these doctors via remote teleconference. And in some areas, you can do this directly on regular mobile networks. But in some areas, it's valuable to have communication systems as well. Satellite communication is also very valuable during times of disaster. And this picture shows us a scene from the typhoon Haiyan that struck the Philippines a few years ago. It was one of the most damaging typhoons, even though they come through regularly. This was a very difficult one for the Philippines. And they had to repair many of the local lines for electricity and for communication. But there's a team called Gator. Has anyone heard of the company called Gator? They have an excellent invention, which is an inflatable antenna for satellite communication. It's small enough you can put it in a small suitcase and take it on a plane and put it in the overhead. And so then you take it out and you inflate it and it can communicate with the satellites. So it was taken to the Philippines during this time and was used to create an emergency communication system. Satellite positioning, I think many of us are using it every day, but I want to highlight a development example. These young ladies are trained to address a challenge related to vector-borne diseases such as malaria. So who can tell me how we might use satellites to monitor or improve management for malaria? Any ideas? If we want to find out where malaria will be and then make a plan to address it. We want to follow the mosquitoes, and how do we follow mosquitoes from space? Any students have an idea? We might need the microphone. Who wants to give some ideas? How can we track where mosquitoes might be from space? Yes? Suggestions? We have an idea that maybe they will be where the stagnant water is located. What else do mosquitoes like? Where do they like to live? Suggestions? Swamps? And what about the swamps do they like? It's humid, yeah? And what else is it true? Good. So that we know from, there are people who study mosquitoes a lot, and they can tell us that mosquitoes like areas with certain temperatures, humidities, and types of soil and vegetation, and certain levels of standing water. They like water that's still and not moving. Because how are mosquitoes born? Do you know how mosquitoes are born? They're born, their eggs are in small pools of water, right? So shallow water. Now, once we have the information about the kind of environment mosquitoes like, we can use data from different kinds of satellites. Some satellites will tell us the kinds of soil or ground cover there is there. Some will give us the elevation. How do you measure elevation from satellites? Do you know? I hear radar. Who knows some of the missions that have done radar measurements for elevation? There are some famous ones. Some from the Europe and some from the US. What do you have? Say it again? Cryosat. Okay, thank you. Especially for ice, right? And on the US side, there was a shuttle radar topography mission. It was done actually a long time ago, but it covered the whole world. And they had 90-meter and 30-meter resolution. And they recently released the 30-meter for the whole world. So now you can have a data set where you can see the height of the land all over the world. And there are other missions. What are some of the other European radar missions? Do you know? From Germany and from Italy? Louder? I heard it. So Tandem X, yeah, it's coming from Germany, yeah? And here in Italy, there's a SAR mission that's very important and famous. You should be more patriotic here. Yes, do you know? Okay, good. Now I'm just thinking of the name as well. I'll come back to you though. But it's good. So if you have a radar data, you can find out the elevation of the land and estimate where you will see standing water. And you have the images and the measurements of temperature and humidity also from space. But they're all from different satellites. So the idea is to combine all that information into a model. The first model tells you where the mosquitoes might be. But you're not finished. The second question is, did the mosquitoes bite any people? So now you need a model and data also about the people. Where do they live? And what kind of population density do you have? But the third question is, was there recently a case of malaria? Because sometimes you might just have mosquitoes biting people, but they're not spreading malaria from person to person. So you need 3 kinds of data. One is about the environment. The second is about the population. And the third is about medical data. And ideally, you want to put all this into one combined computer model. If you're interested to learn more, I've written a paper about this topic. It's on the website for my research team at Space Enabled. You can search for that. And there are teams in South Africa, for example, that are already applying this information. And that's where these ladies come in. Because let's say you identify with your very nice model. Here on the map, we have the highest risk for malaria in the next month. What should you do next? Now you know where to go. What should you do? Any suggestions what these ladies can do? They have a mission now. They're going to that place on the map. What will they do when they get there? What was it? You recommend they kill the eggs?
The eggs of the mosquitoes.
Any other suggestions? Keep that in mind.
They give vaccine medically.
So we have the idea of vaccinating for the malaria. Any other suggestions? Other ideas? Those are 2 very good examples. So on one hand, there's the possibility to find where you expect to see the mosquitoes laying eggs. The vaccine is interesting because, in fact, it's been under development. I think it's both new, and so there's some risk there, meaning we should ask the community, do you want to use the new vaccine? Or another method. Actually, there's a need for community dialogue about it, but yes, we should think about the vaccine. These ladies also, they take a spray and they go into people's homes, because the goal then is to protect one household by spraying the walls and also giving the children bed nets to sleep underneath. So now what they should do is they have the special masks, and they're going into the house to spray the walls and to spray the bed nets. And what they should do is use their phone, which has a nice satellite remote navigation radio, and they should mark, here we sprayed. And for every house they go to, they should mark. And somewhere back, you should send the data and have a nice map showing all the houses that were marked. Some houses might not have been on the map originally, but now you've added them because you walked to them. This other group is doing what you said. Yeah, he is actually spraying in the areas with standing water, and he is spraying where the eggs might be. So these kind of techniques are already being used, and the goal is to use them very systematically. So the whole area that's under risk is either sprayed, or the homes are sprayed, or there's vaccines, or the clinics are designed to catch whenever there's a new case of malaria before it spreads to other people. So you can see you need satellite Earth observation, first to find the map of where you should go, and then make a plan for all the places you visited. And sometimes you might need satellite communication also to come back and say, we have communication as we travel to rural areas. So space is integrally involved for malaria monitoring and other vector-borne diseases. Who knows other diseases like this that are spreading through mosquitoes? We have more now. Ebola? Ebola is actually usually not through mosquitoes, I think. But yeah, but it is something that maybe you can track, the other vector, yeah? But we have some other ones like dengue. What do you have? Chikungunya. Fun to say, right? Not fun to get. And Zika more recently, right? So in all these areas, they're all examples where you can use the same technique. Good. So now you have our experts in how to use space technology for vector-borne disease. It's very good. Let's go on to microgravity. Now, this one may be more confusing because the question is, does every country need to be involved with microgravity research? How many of you think yes, that this is important for every country? All countries should do microgravity research. How many of you think no, it's irrelevant, it's just something extra? Why do you think so? Oh, you're just raising your hand because...
I don't know how microgravity can be used, and so I don't.
Thank you. It's a good question. Actually, it's a little more tricky example because, of course, with Earth observation, you say, well, you have a problem, you map it, and you go. With microgravity, I think we should think longer term. First, we can be thankful because the International Space Station is an amazing example for international cooperation. How many countries were involved with building the station? 15, and it's about right. It depends on whether you count. It was 17 originally because anyway, Brazil was involved at the very beginning. They then transitioned out. About 17 or so. And of course, it includes the Space Agency of Europe, which includes many countries. I heard 22 is maybe the right number if you count all the ESA countries. Anyway, it's about 20-ish countries. So it's a great example where many countries came together, but of course, many countries have not been directly involved. Now, if you ask NASA, they'll say about 95 countries have done some research on ISS. This is very good. But how many countries are there in the world? Yeah, I think about 195. I guess you have to be careful which political lines you draw sometimes. But we'll say about 200 countries, right, in the world total. So the question would be, what will be the benefit of having more countries be involved with research on the ISS? What are the topics we study in microgravity? Who has some examples? You all know this. Go ahead. We study how to grow food, and part of the reason is because we want to see if we can grow food for astronauts. If they're traveling to Mars, there's no way to refuel the food regularly, so we must grow some of their own. But what do we learn about food on Earth when we grow it in space, do you know? It's possible to take the results because, when plants grow in space, they're doing what they naturally want to do, and the gravity is not the main impact. So it tells us something about the behavior of the plants when you take gravity away. It can give us ideas because actually there are people who are interested not just in, they want to increase our food production globally, and sometimes there's not enough soil and land to do this. So some are doing things called vertical farming. They try to grow things on walls or in tiered levels. So space is another example that is kind of like that, where if you can grow something in space, you can probably also grow it very efficiently on Earth. Because in space you have to give all the right water and light and nutrients to make it grow perfectly. And if you have that knowledge very well from space, it also applies to scarce environments on Earth. So hopefully we can improve production of food by doing it in space as well as back on Earth. In fact, right now, the company Target, you guys know Target? It's a very big company in the US for selling everything, meaning they have very large stores, and you walk in there and you find your clothes and your electronics and your books and your food all in one place. So they use a lot of cotton, meaning a lot of their products are clothes made from cotton. And they are doing a project now on the space station to explore how cotton grows, because now it takes a lot of water. And this isn't a chance to explore the science of growing cotton, to find ways to reduce the water, because we don't have enough water to grow all the cotton for all of our clothes in the future. This is one idea. What else do we study on microgravity? Yeah, so we were interested in molecular level studies for human body and for materials, right? So for material science, sometimes there are ways to manufacture materials in space that are different in space versus on Earth. And there's a lot of new biology we're discovering, whether it's in the human body or in plants and animals. Physiology. So yeah, some of it is at the level of organs and how they operate, but also there's teams now exploring genetic level exploration, either to do gene sequencing or to think about changing genes. It'll be the next generation of work. So the goal is to use microgravity environments and say, if you take away gravity, what's left about the behavior of this thing? And what I would propose is that if we see more science experiments coming from the countries that usually are not involved, that means the science questions will be different, and it's more likely to involve the topics that come from those countries. So the diseases that are of interest to them and the materials that are of interest to them, they're more likely to be represented when we have more countries involved. And in the future, you can expect to see more places to do microgravity research, right? Who knows how long we'll have the ISS? When will the space station be approximately retiring? It's a good question. You might hear different answers, 24 to 28. We don't know exactly. We know that technology-wise, the engineers who are working on the space station think maybe it can survive technically until about 2028. But we can expect new companies to form that will make space stations commercially. So who would like to be in a company making a microgravity platform for space? This is good. I mean, you should think actually, literally today, what I did before I came, NASA has a solicitation now for a study asking, what will be the future to commercialize low Earth orbit? It literally wants to ask, why would you start this company and how will you do it in the future? So it's right now the right time to think about it. In 10 years, we should see new companies that have small space stations. And you pay them a fee and you put your experiment there. And we hope that there are people from all over the world doing this science and bringing that knowledge back to Earth. So we think we'll see new examples in the future. For now, this is not fully finished, but we actually are curious. Remember the picture I showed you earlier of the water hyacinth, the plant from Benin? I want to put it also in space. And the reason is that it has this property already that it absorbs water. And there are some people who are using it in a vertical garden on a wall, and they're using that plant to grow a second plant. So there's no soil, there's just one plant holding water that lets another plant grow. And I'm wondering, can you do the same thing in microgravity? If you're growing plants and food for the astronauts, can this water hyacinth absorb enough water and nutrients to hold that and allow other plants to grow? So if we have the chance, we'll try this in space. And then we'll find out if that brings benefits back to Benin as well. So there's not time to talk about everything, but I'll share some more examples. The other example is in space spin-offs. I just mean here that you have a technology designed originally for astronauts or for space exploration, but then we take it back and put it back on Earth. So my example here is from a water filter system. Now, why do astronauts need a water filter? Who can explain? How do they use the water filter in space, on space station? Thank you, you're very brave. Wastewater is recycled. It has all kinds of wastewater from the shower and from the urine and from the food preparation. And all the dirty water has to be used again because we're waiting for the next cargo ship, right, to come and resupply. So this system is actually the one used on the ground. You can put it in a very large truck and take it to any lake or any source of dirty water and pump it through and get clean water out. But the filter inside is the same one used inside the space station. And it happened in this case because there was a nonprofit doing water management and addressing disaster areas. And they had a friend who worked for NASA, and they happened to share that they had this technology for filtering the water for the astronauts. They said, well, we need that technology to filter water for our work. And so in this case, just the two friends, they transferred the technology from NASA to the nonprofit. But it doesn't have to be that hard. In fact, NASA has a nice website. You should actually go and look up a place that says the patent gift. NASA has made a gift of many of our patents to the world, meaning they were technologies invented by NASA that were patented by the government. But they said, well, we're not using them, and in fact, we want somebody else to use them, especially if they're starting a small company. So they just published all the information from the patents on a nice database, and you can go search for it. And you can use it without even asking NASA. It's free for you. So they have this website where the intellectual property is there, and they also have other ones that are not free, but you can pay a small fee. So please check out from ESA and from NASA what the technology transfer teams have provided, because they're trying to spread the technology, but they need people like you with an idea to change the world, and take the technology and apply it. This is for you. I mentioned inspiration, and we can talk about space science. Can anyone see what country this is? Can you see the name, or can you guess? It's in Ghana, which I mentioned earlier. When I went to visit their minister, I also visited their first radio telescope. Who knows the name of the very large radio telescope project happening in Africa and Australia right now? Has anyone heard of it? I think I heard it. I hear whispers. There's a project now you should learn about. It's called the Square Kilometer Array. It is going to be the next generation of ground-based radio astronomy. Who here enjoys astronomy? Anyone? Just for fun, for science? Yeah? So these telescopes, there's going to be a series, about 60 in South Africa, and then several more spread to other countries. What's the benefit of having multiple telescopes in different parts of the continents of Africa? Why do we want so many, and why do we want them spread apart? Who can explain? Go ahead.
You can use interferometry techniques to basically have a larger telescope.
Thank you. You mentioned the word interferometry, meaning that we want to combine the signals from the multiple telescopes in a very nice mathematical model that will imagine as if we had a telescope almost the size of most of Africa. And in this case, also there will be telescopes in Australia. So really we have almost a continental scale observation. Their goal is to observe information about the early history of the universe and to study dark matter and dark energy. So this is a next generation, and it's an international collaboration. But the fun thing is that so many countries are involved that in the past have not had very large-scale radio telescopes before, and this will introduce them to the field. So there's new jobs and new education opportunities for so many people, which I count also as development. And here you see the example in South Africa where they will have about 60 radio telescopes also added. And so this is happening over the next few years. You can watch as new ones are added, and then data will be shared soon. Also, people around the world are starting new satellite programs. And for my PhD, I studied countries like Venezuela, which you see here, that are creating new programs to teach engineers to build satellites for their national satellite agency. This is my friend Elika, and she's a satellite engineer for the Venezuelan National Space Program. And this is Hala. She's from Sudan. And she and several students built a CubeSat in Sudan kind of on their own. They thought it would be fun to learn, and they just trained themselves to put together the pieces because they were inspired by this technology from space. And countries like South Africa and Kenya, which I know we're celebrating the collaboration between Kenya and Italy to launch their first satellite. Countries in Southeast Asia like Thailand and Malaysia and Singapore and Vietnam, they all have emerging space agencies that are operating satellites to monitor the environment and for communications. So we're seeing this around the world where space is now a part of many countries' official policy, and they have, both in the education and in the professional work, activities to spread space for their benefits. This is in Nigeria, and here they've had several Earth observation satellites and several for communications. I'll just close by showing what we plan to do in the future, because we're seeing a lot of changes now in the space industry, and maybe you've seen some of the key companies that are affecting the future of launch and manufacturing in space and the new services we expect to see. So how many of you watch the news of new space companies that are inventing new things or flying new rockets? Yeah? There's some examples here. I want to just highlight first that we're in a new transition point. Over the last 20 years or so, this is a traditional satellite. It's built by NASA, and it's very good. It has excellent science, and it's very high quality. It will last for decades in space, maybe 2, and it's very expensive to build in a special laboratory. But of course, we also have small satellites. What are these called? CubeSats. And how many units are these? Well, they're each 2, yeah? There's there's like 4 units here in the picture. Sorry, it's a trick question. There's 2-unit satellites. And of course, they can have very, not simple, but very accessible ingredients, right? They can be made from the parts that are also in our cell phones and other electronics. So this is a new idea that countries around the world can have small satellites, very small, but also medium-sized, that's affordable for any national budget. And of course, even children are involved. These young girls are from a primary school in the US, and the whole school collaborated to build a satellite, and it was launched by NASA to space. So NASA was very inspired by this example. But it's to say that everyone can have a role if they want to. They can learn this technology. It's very affordable, and everyone can do it. And this means in the future we'll see new services. Do you guys know about Planet? Who has heard of the company called Planet? It's a US company. Earlier we were talking about Silicon Valley and whether they have a role in space. This is one of the startups that's come out of Silicon Valley. It was really some employees from NASA who decided to build a very simple phone-based satellite, meaning a satellite based on their cell phone. And now it's led them into building these 3-unit CubeSats that take pictures of the Earth. They have over 100 in orbit now, and their goal is to take pictures of everywhere on Earth every day. There's a lot of new data that is not science quality, but it's very useful for new information. It's also not free. So if some of you are starting a company to use Earth observation, you can buy some data from Planet, but you need a business model to sell a service that gets that money back for you. Other companies are also doing the same. Have you heard of Sierra Nevada? What are they trying to do? What is their business? Yes, their goal is for space tourism, and they're designing this very beautiful small shuttle. It's like smaller than the space shuttle, but similar shape. And for now, they have a contract to do a resupply of space station with the same vehicle, but their long-term goal is to take you to space, all of you to space in the future. Companies like Blue Origin, do you follow Blue Origin and watch their videos online? They do a lot of good launching, and of course, they are also designing new rocket engines, which is exciting to have innovation in that area, and of course, doing the reusable landings. Same with SpaceX. Are you watching their landings as well? It's beautiful, right? I mean, to land a rocket standing up on a boat while it's floating in the water, it's pretty crazy, right? So this is a new era, right? It's a time when we are seeing new approaches in space, which should make it possible for more countries and more people to be involved, especially because of companies like these that are going to add more ways for things to go to space, for research, but also for tourism and for other services. And I mentioned Rocket Lab. Have you heard of Rocket Lab? They're fun because they just announced that they have finished their first set of testing, and now they're open for commercial orders. So if you build a small satellite, they would like to launch it for you, because they are specialized in launching only small satellites, which is the first time that a commercial rocket has kind of had this mission. So it's very good. And we'll see maybe Virgin also with their Virgin Orbit mission to do the same. So it's a good time to see new ideas, and you can be next if you're interested in joining or creating a small company. But know that all of them have been working hard for years. They're achieving these successes after many years of work. Who knows Made in Space? Have you heard of them? They put the first 3D printer on the space station, but now they're asking what's the next generation of manufacturing in space. And they have a project now with a company that does fiber optics. And they want to see if they can manufacture a very high quality fiber in microgravity. So these are all changes that are showing how we are going to see new services and new capabilities in space that hopefully we will all use, and some of you will help to create. And we're going to use all these tools from our team to help apply these for sustainable development. And the last thing I wanted to share is a few ideas of our research. Our next phases are to do research projects that help to close some of the gaps we mentioned today. One is in modeling, and that means we want to design computational models that help us understand, first, what's happening in the environment, second, what's happening with human behavior, and third, how we can design a technology system from space to respond to the challenges of the environment. The second area is satellite engineering. We have a research lab to build satellites, and we want to do it for two reasons. One is to apply it to an application like we saw in Benin, to monitor things like the plants. But the second is to invent the future generation of satellites, because now we're creating too much debris. Our small satellites just go and we use them once, and then we throw them away. And we could do better, perhaps, if we can, on one hand, use the nice methods you all have here for understanding the orbital perturbations more clearly. But we can also design them differently to either be reused or recycled or manufactured on orbit. The third area is in data science. Some of my team are experts in artificial intelligence, and they are thinking about how to use the data we have from environmental satellites and combine it with other kinds of big data from the internet, from social media, and make new insights using artificial intelligence and machine learning. Is anyone here studying machine learning? This is more on the computer science side, yes? But I think we can combine our satellite engineering knowledge with the computer scientists who understand machine learning, because they know how to take a very large data set and ask a computer to find what's important. And actually, we don't know why the computer is doing it. We just know you give them an example and say, if you want to know what's happening in this data set, such as where is the plant, you give examples where you've already identified the answer and let it train from that. And then you give them another data set where you've not identified the answer. And then the computer finds some rule or some pattern and gives you a result. But it's a way to make data that's very confusing to a human more automated to analyze. So we're trying to use that as well. So I'll just close with that and say, this is where I get to work every day, and so I'm very fortunate to go to the Media Lab. It's a place where faculty are working across many fields: engineering and art, design and science. And our goal there is to apply space technology to advance justice. And I'm so glad to make connections with people like you, because we are all going to work together in the future to use space technology to meet our SDGs. So thank you so much, and I welcome your questions.